here. Let me just see where we stopped. So I've updated it with the material we covered last time. So let me just go to the end, make sure. Okay, so we talked about logical operators. Okay, great. All right, so let's start from there. So you know about logical operators, you know that we borrowed that idea from computer engineers. And the main thing that you need to remember is the truth table. They come with a truth table. And this is what it looks like in if you were to build these components, if you were to buy hardware, and if you were to hook them together through the breadboard and put wires, basically you are sending electricity through these two wires into this component. And then the component does what it's originally designed to do and produces either electricity or not at the end. So the three common things that we're going to use in this class are a logical or, and not. We call it logical because ours is in software. We can't touch it. These components, if you Google on internet, you can actually buy them and touch them. So this is hardware. We are software engineers, and we borrowed this from our counterparts, our colleagues in in hardware engineering. So the way these components work, you can string them together, and just like they're stringing it here, see here you have an AND gate. The output of AND gate is then fed to OR, and then another AND gate, its output is fed to another OR for another result. Here we have OR, here we have what they call NAND, and that's fed to AND gate, and then you get result. So as you see, it can become very complex in a hurry. We're going to use OR, and not, but just so you know, there are other gates available for use, okay? So this is what you need to know. Instead of having wires like they have, wire here, we have an expression. So that expression, whatever that expression evaluates to, is basically true or false. And then you have another expression, as you see, and, or, they are binary operators. They require two operands. Expression one is one operand, expression two is another operand. And the result, the way this is designed to work, is just like its counterpart in hardware. If both expressions evaluate to true, then the end result is going to be true. The overall expression is going to be true. Now, is it always two? No, you can put more. You can put 6, you can put 8, 7, as many as you want, but this is how it works. Each expression has to evaluate to true in order for the entire expression to evaluate to true. Any combination, if you have false and is very restrictive, it's not going to evaluate to true, okay? Or is different than and, pretty much like the flip side of it. The only time you're going to get false with or is if both expressions evaluate to false. Otherwise, you're going to get true. If one of the expression evaluates to true, it's true, okay? As you see, and is very restrictive, or is not. And then not just flips the sign. If this is true, it's going to flip it to false. If this is false, it's going to flip it to true. And we're going to see use of that too, especially with conditional statements, loops, and things that we're learning and are going to learn in this class. Okay, so this is a good slide for you to print. You can always refer to it, and after a while you will know exactly how they work. It's very simple, and both need to be true, or only one needs to be true. If both are false, you get false. So that would be Cliff Notes version of what you're looking at on your screen. It's a mechanism. It gives you ability to tackle more complex logic. And these are the C++ symbols, ampersand, together, strung. They symbolize and. Pipe symbol symbolizes or, and then not is exclamation point. How would they look in C++? Parentheses, then expression A, ampersand, ampersand, expression B, close parentheses. All right, so let's look at it in a little more detail. A logical AND, as I mentioned, operands are expressions. And the only thing that you're concerned is that both of these evaluates to true. Everything else, any other combination is going to be false. And here's a C++ code example. We're asking the user to give us number between 1 and 100. And then you're testing if it is greater or equal to 1 and at the same time less or equal to 100. So if this is true and this is true, then this cout will execute. Otherwise, the other cout is going to execute. I'm going to talk a little bit more in more details about lazy evaluation. So we're going to look into that. That's very, very important. Before we discuss that, as a programmer, you need to know your input ranges. When you're interviewing the business person or project stakeholders who are asking you to do something, you need to know everything about the input that you're getting. In this case, we are capturing something that we're all very familiar with, which would be student score. Student score has a range where it's valid. Anything outside of that range is invalid. You need to know that, and if it helps, I'm very visual. I draw things in order to understand them. For those of you that are like me, here's a visual representation. This here is my valid range. Anything outside of that range, in my code, I'm going to display an error message. So less than 0, greater than 100 are error conditions. And then I'm using logical AND here. We can also use logical OR. But here I have quiz score is greater or equal to 0 and at the same time. So both of these expressions, both of these conditions need to be true for that quiz score to be deemed valid in your program. And if that's true, you just say quiz score is valid. Otherwise, you display error condition. Okay, so that is one way to do this. Another way is to use logical OR. And we know a little bit about logical OR from previous discussions. So we're looking only for one of these to be true. Okay, so let's look how this would look for our example. So here we're flipping it. See, this is logical OR. So if quiz score is less than 0, I don't need to check whether it's greater than 100. It is not valid. If quiz score is greater than 0, let's say 101. Okay, so this one is going to return true, and then this one is going to return false, right? So, pardon me, if it's less than 0, this one is going to return, if it's like 101, so this is false. This one here is 101 greater than 100. Yes, it is greater than 100. We're going to go into this block of code and display an error message. And I want you to notice how they pretty much do the same thing. It's just personal choice or preference. When you use logical OR, your error condition is here. Look at the end. Error condition is down here. So if this evaluates to true, you continue and you determine their grade. So you know that you have valid score. Otherwise, you just display error message. In this scenario, if this evaluates to true, you're displaying error message. And in the else branch, you figure out what is the grade. You say, okay, your grade is C or B or whatever. Okay, so keep that in mind. So the takeaway is know your ranges and then use your logical operators to exclude things that are not valid. You don't want these things in your program. You don't want them. One, you're writing precise code. Two, you don't want any chances that your program could crash. Okay. And then last one that we need to talk about is the not, logical not. Notice here what I'm doing. I have 10 and 20. Is 10 less than 20? Yes, it's true. And then I reverse it. I reverse it for the purpose to go into that or not. 10 is less than 20. That's true. I put this sign in front of it, which is not. So true becomes false. And then I execute this line of code. So we'll see this in a little more detail. Just understand that there's an order of operations here. Expression evaluates first, so true or false. Then the not reverses that. You'll use this a lot with loops. You'll use this a lot with conditional statements. Just understand for right now, the takeaway from this slide or this discussion is, okay, expression evaluates first. I may need to reverse that, whatever it evaluated to, I may need to reverse it to the opposite. All right, and then the precedence, you need to know the precedence of operators. Not has the highest precedence. And or they're a little bit further down the scale, you have these other operators that are more important. Okay, so that's the hierarchy. All right, so here is an example of a source code where we test for validity of user score. So this is a long version. Let me show you where this, what we're learning now exceeds example like this. So see, you have this. Let me share this with you so you can try on your own. So right here, there you go. And please pick it up. It's in the chat if you're working with alongside with me. And let me fire my sea lion. Let's have a look at this real quick. So let's do a new, and today is, I believe, 30th. And this is going to be source code 00, logical operators. Now let's have a look at it. So I don't have logical operators here. I am testing whether quiz score is less than 0. I display this error message. If that is not the case, I'm testing. So if I have like 111, I'm going to test to see if it's greater than 0. Pardon me, greater than 100. If it is, I'm basically just repeating this code. And you know the acronym I showed you in the previous lecture, do not repeat yourself, right? So DRY, do not repeat yourself in programming, holds true. We need a way to combine these two. And then we have the else part where we compute the grade and display it. Okay, so let's see if we can fix this. I'm going to copy this code. And let's run it. Let me show you how it works. I'm going to put the breakpoint right here. I'm going to use debug so you can visualize what's taking place. We're going to enter something correct so you can see how it works. It says enter your quiz score. Let's say 99. Right? So is 99, so it gives you this, less than 0? No, it's not. So it's going to skip that. It's going to come here. It's going to try to test that. That's not true. Then it goes here and determines that this is an A and displays and says 99 is an A. If we try to enter something that's outside of the range, say -1, it's going to go here and test is -1 less than 0, true or false? True. Because it's true, it's going to go in here, it's going to display the error message, it's going to say exiting, and then please watch the blue line. It goes right here, skips everything else, and we are done. Please run the program again with this program run. And similarly, if you try to enter something larger than the range, an error message displayed. So 111 is 111 less than 0. No, that's false. So it skips it, goes here. Is 111 greater than 100? Yes, it is. Goes in here, prints this, and does the same thing. So the program works, nothing wrong with it. However, it has some repetitive statements. You're repeating yourself. 1, 2, it's long. 3, these error messages, that's copy and paste. Not a good thing. So let's copy that and let's write it a little bit better so that we understand what the problem is. How do I do that? I'm going to use a logical operator. So if it's less than 0, here I'm going to use OR, and I'm going to copy this one here, or greater than 100, like so. I'm going to display an error message. Otherwise, I'm going to ignore this, and in my else part, I'm going to compute that grade. In the previous lectures, when we used single conditional statements, I assigned letter grade to Z in case we got some crazy result that it displayed Z, so it alerted you, okay, there's a problem, there's a logical issue in my code, logical error. Here, I'm not assigning it to anything. I don't need to assign it to anything because by the virtue of the fact that I'm testing for the range, I don't need to test one more time here. I don't need an else if to see if the score is less or equal to 100, because if it's not less than 60, less than 70, less than 80, less than 90, it's definitely less or equal to 100. So I don't need to worry about that. One less test here in this scenario, as opposed to if you review code from a previous lecture, you'll see that we have an extra else if at the bottom. Okay, so from that standpoint, this is more efficient. Okay, so let's test this. Let's see what this does. And I'm just going to run it in regular mode. What is your quiz score? -1. It says not good. Let's run it again. What is your quiz score? 111. Not good. Let's run another quiz score. Let's say 11. 11 is an F. And if you put the breakpoint, you're going to see how that performs. For some reason, debug is very slow in. I need to figure out why. Okay, quiz score -1. Okay, let's try one more time. Okay, see, it takes a while. I don't know why. Okay, so -1, and it's here. All right. So it's looking and it's saying, is -1 less than 0? If that's true, okay, so we're going to go here, and it says this is the case. Then it jumps out and it's done. Notice I'm not using, I could put return statement. I'll show you that too, but I'm not big fan of multiple exits from all over the code. You should have only one single exit program, so that way you control your code. Any questions on how this works? Actually, we used logical OR here. I'm going to switch this to logical and then not, so that you can see these things. Any questions, guys? We good? Guys, are we connected?
Yeah.
Yeah, we're good.
Okay. All right. Thank you. All right. So let me copy this. Let's make it, this was OR. Let's make it AND, so you can see that as well. So new project. And this is source code. Let's make it 02. This is logical AND. Okay. The previous one, I'll rename it. It's logical OR. And let's just flip it to AND. So this one here, I'm going to make it logical AND. And then what I have to do, if quiz score is greater or equal to 0, and quiz score is less or equal to 100, I gotta do this. So the else part goes in here, like so. And then the error part goes in the else part. So we have that, like so, and then this part goes down into, and that's it, it's done. All right, so that is the code here. Let me share it with you so you can see it. Go ahead and copy if you're working alongside with me, and let's run it real quick, see what it does. Let's enter -1, works. Oh, here it says, wait, -1 is an F1 second. And here, oh, yeah. I copied, see, copy and paste will always get you. Always get you. I copied one extra line. I'm sorry about that. Wasn't paying attention. This needs to be part of the if branch. There you go. Okay. All right, so let me share it with you again. So copying and pasting is not a good programming practice. So try, if you do it very carefully, don't rush. All right, let's run it. Let's see what it does. Enter -1 and invalid code. Let's enter 101. So 101, and it's invalid code, okay? And then let's enter something valid. Let's say 78. 78 is a C. Beautiful. So it works. So you see, we just flipped it. We flipped, like in that short example in the presentation where I showed you how you can flip them. You do that here. It doesn't matter. It's just a block of code. You substitute it. Now, some of you are probably wondering, how can I use not with this? So let me copy that. Let's say now here, this is what it boils down to. Personal preference. They both work, as you see, and or work. Figure out, where do you want your error condition to be? Do you want it here at the bottom and your solution to be here? Or do you want your error condition to be on top and your solution in the branch? Pardon me, in the else branch. Which branch do you want to execute your solution code, and which branch do you want to execute your error condition? When the program encounters error condition, which branch is going to serve that scenario? Okay, so let me show you how you can do that easily with just one of them. Here I'm going to demonstrate the not, logical not. So this is logical not. We're not going to make many changes here. So this is, hopefully I spelled it correctly. And let's have make a quick change. I'm not going to change anything in this expression, but I'm going to move this code down in the else part, right here, like so. And I'm going to take the else part, I'm going to put it in here. Okay, because I want my error condition to be on top. Okay, now, in order to accomplish that, I'm going to put a not here. So this, if it evaluates to true, I don't want it to go. So see, look, let me show you what it does. Let's do it without the not so you can understand better. So if I enter here, let's say -1 or 111 or something like that. So here's -1, and it's saying, is -1 greater or equal to 0, or is it less or equal to 100? And see, it goes here and it starts to evaluate it. All right, so it's going to display that -1 is an F. Okay, so you're probably asking yourself, well, why are you doing this? Well, all I have to do is this expression evaluates to false. And because it evaluates to false, it goes to else part. So that's I think everybody knows that. Have any questions about that? You know, if this entire expression evaluates to false, then we're going to end up in the else part. Yes or no? Yeah? Yeah. So because of that, that's why we're going here. The only reason I'm doing that is because I'm going to put this. The only reason I've put this guy in here is to reverse, because I know this is going to evaluate to false. If it evaluates to false, I want to flip it and make it evaluate to true so that I can execute the error, display the error condition. Otherwise, I'm going to do this. So please watch. With this one little change, this program is going to behave slightly, totally different, not slightly, totally differently. So here's -1. It says error invalid condition. So look, invalid range. Let's do it with debug so you can visualize it, what's going on. So here's -11, let's say, and it says, okay, is -11 greater or equal to 0? That's false. Is it less or equal to 100? That's true, but false and true gives me false. So this expression evaluates to false. I flip it with a not, make it true. Now please watch. It goes here and displays this, and then skips and gives me return. Okay, so that's that. Now, if I was to give a correct range, it's still going to work great. So let's say my quiz score is 91 or 98, it doesn't matter, 91, and says, is 91 greater or equal to 0? Yes. Is it less or equal to this? That's true. So in that case, I would enter this and display that this is an error, but because I put a not, it's going to flip it and it's going to execute the else part. And that's it. You're done here. It's going to show you what the quiz score is. It's going to say that 91 is an A. Okay, so you can do that. See now the power that you have. This is your tool chest, if you will. So you know how to do a lot of different things and you pick it. And one of those is, okay, my personal preference is mine. Personal preference is always to have error at the bottom and I do my solution on top. If you like that, do it that way. If you don't like it, do it this way, present the error, then provide the solution. But there's no rule that it has to be on top or bottom. That's programmer's personal preference. Okay. Any questions, guys, on this?
No.
No, we're good. Okay. Let me show you one more thing, what I don't want you really to do. But you should see it. You should know how to do this, just in case you're asked on an interview. So it's going to be source code 04, and this is, let's say, logical operators. Do this. I'm not going to have the else part. Let's do it like this. Let's do it regular. And let's make this, it's less than 0 or greater than 100. I'm going to do that. We're going to display an error. We're not going to have else part at all. I'm going to move this here like so. And then in here, we're going to put a return. You can do return. Okay, or you can do exit. So return is one way. Not a big fan of this. Not a big fan of this. It works. Some people will argue this is efficient, you know, blah, blah, blah. But look, if you go -1, it's done. This part is unreachable because of this return. And if you look at it, if you put a break statement in here, you're going to see that this is unreachable. This code, it will never be reached if you give it something that it doesn't like. See, now we drive it ourselves, goes here, goes here, goes here, return, and it's done. Okay, that's one scenario. Now you can also use is a exit, and then you can do failure this. And if you run it again, it's going to do the same thing. Let's say we enter -11. I guess the zoom, too many things running at the same time. Okay, so we do this, we do this, we do this, we do this, and it works, and you know you are done with this code. Okay, very abrupt, these things. The reason why I'm not a big fan of it is because if you pepper your code with all of these exits and returns all over the place, simple program like this, you can see it. But as your code grows in complexity and you have multiple exits, where did you exit from? So for you, as a programmer, you need to control your code. One exit is better. So that way, when the code exits, you know exactly where it exited. Okay, so I'm going to put here that I'm not a big fan of that. Use else. Prefer that you use that. Okay. All right, so here, let me copy that. Let me paste it. So you guys have that just in case you go for an interview and they ask you this thing. All right, let's continue. So let's review what we discussed so far. So we had this solution, we improved it. So we used logical OR here. Then I need to discuss what I told you, lazy evaluation, or what they call short circuit evaluation. Okay, so this is an optimization that is provided to you by compilers, okay, for logical expressions. And as soon as the overall expression's result is determined, it stops evaluation. So it saves you computing cycle. It's going to make your code run more efficiently. So to understand that, you need to know the truth tables. So here, let's look at the example that we were using in our code earlier. So here's my expression. I have overall expression consists of two expressions. this one, and this one. So you see, this is expression 1, this is expression 2, and then this here is logical OR. And I need to be aware of how this evaluates. How does the code evaluate, guys? It goes from top to bottom, and then what else? What's the other order of evaluation? Please, somebody. Left to right. Very good. So it's going to encounter this expression first when it starts left to right. So if the left hand side, this is your operator. If the left hand side operand evaluates to true, because this is OR, if you look here, if this evaluates to true, this evaluates to true, doesn't matter that the second one is false. The overall expression is going to evaluate to true. So this one evaluates to true, see, like so, like here. I color coded it so it's easier for you to visualize that. Then the right-hand operator is not evaluated. So you're saving yourself one test. Now picture that when we had the else part without the, the first one that I showed you with that repetitive code, you still went and evaluated the second part. So here you don't, right? So the second one is not going to get evaluated. So that is known as short circuit evaluation, or we also call that lazy evaluation. So some textbooks will call it short circuit. Some will call it lazy evaluation, but basically it's the same thing. You need to know both. Now here's logical AND. Again, you need to know you have two expressions. You have the operator between them, and you need to know this table. If the first expression, because it's left to right, evaluates to false, there's no need to evaluate the second one. Here is what's going to take place. This second one, if this is, let's say, -1, the compiler will never bother checking if this is greater or equal to 100, so your code is more efficient. Performance gains, time is money, and safety. So you as a programmer, always consider how this works. Remember, you don't want to be a good programmer. You want to be a great programmer. These are the little details that's going to separate you from average Joe and Mary. Okay, so that's what you want to do. All right, so here I have a challenge for you. We don't have enough time to do it, but let's have a quick look. We want to write a program that's going to prompt the user to enter a character. And the program is going to determine whether this is a vowel or a consonant. Okay, so notice here, as a programmer, you're looking at this and you need to notice things. You need to learn how to read your requirements. And I put here, note the case of the letters entered and displayed in output statements. Your output needs to mimic this exactly. So if this is in capital letters, this needs to be in your code. Here we've entered lowercase. Here we've entered uppercase. Here we've entered digit, and we've entered non-letter, non-digit sign. Okay, so you take a look at that. Jot down notes that input can be lowercase and uppercase, and it doesn't matter to your program. Your program needs to react correctly to it. And then you also note that what is the input? Letters, numbers, and other characters. Okay, so pretty much anything that's on your keyboard. Right, so let's have a look at it. Let me show you one solution. Then we're going to walk through, walk through it to make sure that this is that we understand that, and then we're going to use some other. Well, let's see. Okay, so here let's do new project, and this is going to be 05. Source code 05. I'm going to say vowels. Okay. Source code 05. This is vowels. Let's do it in this window. And let me paste it in here. Let me paste it here for you all to. Okay. So what do we have here? We're prompting for a character. Notice the data type. And I am testing. I'm saying if it's lowercase, and at the same time, see, I'm using the range. If it's greater or equal to lowercase a, and at the same time less or equal to lowercase z, or, so this here is going to give me lowercase characters, range of them. This here is going to give me uppercase characters. So I am certain if this overall expression, see now here, it's a little more complex than what you had in the previous example, because what you have here is you have one expression, then you have and, then you have another expression. Then this here is an overall expression for the AND operator. Then here you have one expression, and you have another expression here. And this here is one expression, right? So these two need to evaluate to true, okay, in order for the overall expression 2 in the OR operator to evaluate to true. Same thing here. This one needs to evaluate to true. This one needs to evaluate to true. And this one will then evaluate to true. Now, because you know about lazy evaluation, if this part here, this expression, the overall one on the left-hand side of this operator values to true, it will never bother evaluating this one. So if we have a letter, then we proceed to figure out whether this is a vowel or not. Otherwise, we're just going to say, please enter letters only. Okay, otherwise we put is a consonant, okay, and so on and so forth, okay? So this is how many? 1, 2, 3, 4 expressions, but you see how they're grouped, okay? And I put parentheses here so that is very, very obvious. Then down here, notice what I'm doing. I don't know if they're going to enter uppercase or lowercase, all right? So I am using built-in function toUpper, and I'm comparing it to always uppercase A. So here, remember how we temporarily did a static cast in the previous examples in one of the lectures? So here, you're not changing your user character. You're just temporarily making it into uppercase for the purpose of this comparison. Okay, so here I'm checking whether it's uppercase A, E, I, O, and U, which is vowels. If that's the case, I display this a vowel. Otherwise, it's a consonant. And then I say, please enter letters only. Okay, so that is what we did here for, let me delete this. So we can run it. Let me execute it. Oops, I'm still in the draw mode. Let's execute this and see what it does. So here I'm going to enter lowercase character a, and it says a is a vowel. Okay, now let me enter this thing. And it says, please enter. Okay, I deviated slightly, oops, from the requirements here. Let me see what we needed to do. Okay, and yeah, no, please enter letters only, please. No, I didn't. I'm doing it correctly. I just thought that maybe we need to display number and all that, but we don't. Okay, so let me enter a number. So here's a number, let's say 8. It says that, and then let me enter uppercase A. It's a vowel. Let me enter non-vowel, let's say M. So M is a consonant, and then let me enter something like this, ampersand. Please enter letters only. Okay, so that is your logical operators in use, or that are your logical operators in use, and you see how you can put that to work. So that's one solution. Okay, now I'm going to show you another solution here. So I have a temp car. I'm doing a little bit more elegant solution. Same solution. So I grab user character, then I have temp car. Okay, and you'll see what temp car does. So enter a character. Then here we compare to figure out whether this is a letter. If it's a letter, we go in. And then in the previous example, guys, notice that I was doing two upper, two upper, two upper, two upper. So again, don't repeat yourself. I temporarily converted here to temp car. Then I compare temp car so to figure out if it is one of these. So I do one. Again, this is going to separate you from average programmer. Both of these work, but this one is going to be more efficient. And you do this, and you're done. Okay. Another thing that you could do, how to use before we get into the next demonstration here. Any questions, guys, about what we just discussed?
On your Sea Lion, when you did the two upper, um, what is the C colon?
Oh, no. Don't worry about that. That tells you that this is a character.
Oh, okay.
This is a professional grade ID. If you do this in um, like one of those browser IDs or in code blocks, or I'm not sure if Visual Studio Code does it, but if you do it here, look, let's do this real quick so you see. I go here and go to syllabus, and let's open one of these. It just tells you, gives you a little bit more insight into what is going on. So look, if I open this guy and paste it like so, it's not going to show that. And it's going to run exactly the same. Please enter character, let's say 9, and it says enter letters only. And if I do that, it's going to say, let's say A. A is a vowel, and so, but it doesn't show you here in Sea Lion. It's just because it's professional grade and it tells you, okay, this is a character. All right.
Okay.
Yeah. All right. So we're back here. Any other questions, guys, before I get into this? No? Okay. All right. So here we have a simple program where you have a scenario where you have a constant speed limit, 70. Let's say that's the speed limit on some road, on a highway, and they're asking you how fast you were driving. You enter the speed limit, and you want to know how fast you were going over the speed limit. Okay, so if you were driving, let's say 50, and speed limit is 70, if you take speed limit and you subtract driving speed, you're going to get 20, but you were not speeding, right? So it's going to tell you what it is. Notice that I'm using ABS. ABS is part of the math function. It stands for absolute value. And the reason for that is if I take, let's say I was driving 90. So I take 70 minus 90, I'm going to get minus 20. So minus 20 is a negative number, and it's not going to be, it's not going to tell me that I drove over the speed limit. So, over or under the limit, when you use ABS, it gives you without absolute value, gives you without the negative sign. So then your code is simplified here. So the reason why I'm showing you this, you could have rewritten, and this would be a good exercise for you to rewrite it without absolute value. How fast were you driving? Capture the speed, and then you can say if is this and that, then, so try that at home to see what you come up with, okay? But you can simplify, always look, there's an acronym in programming. I don't know if I mentioned it before, but it's very, very useful for you to remember this. What does KISS mean? Does anybody know?
Keep it simple.
Keep it simple. Yeah, they say keep it simple, stupid. Keep it super simple. That's what I would say. The simpler, the better. Okay, the less moving parts, the better. So if you think about it, less headaches for you, and that's how you should view this. Okay, So, all right, let's see the next. Let me see what this thing is. Okay, so CMAT, I'm importing CMAT. I'm using calculation that's performed outside of the conditional statement. And then, as you see, I have input, I have processing, then I have output, okay? And I could use, I want to introduce to you equivalent of if-else if. Okay, so please watch. This is what is known as ternary operator. Here is first operand. Here's the operator right here. Okay, here's the second operand. Here's another operator, and here's the third operand. So this is a ternary operator. This is exactly equivalent to the previous code. Now, if you understand this, if you like to write it this way, there's nothing wrong with it. To me, this is less visible than the previous one. Let me just, oh, I'm still in the draw mode. Okay. So to me, this is less visible than the previous one. So see, when you look at this one, look at it, this one I can see better. I can see better because I have if, then I have, but basically what you do is this becomes one, this is your condition, then this and this, these are your operands. If you look at it, I'm going to show it here in a little more detail. So here's one, here's your operator. Here's if this expression evaluates to true, then execute this. Otherwise, execute that. So you see, this is like an if statement. So if this is false, execute this part. Okay. All right. Questions? We good?
Yep.
Yeah.
All right, great. Thank you. Let me show you switch. Very similar to if-else if. The only difference is that the switch works only with integer and integer data types, which includes cars. Okay. So keyword switch, expression, open parentheses, close parentheses at the end, not parentheses, I'm sorry, braces, curly braces, open curly brace, closed curly brace down here. And then you have case, break. So case, value 1, value 2, value 3, value n, break, then default. Okay, so that is the syntax. I'm going to break this into pieces to see what this is. So very important that you have this break statement. Okay, when you execute your code, it goes here, it says is whatever variable is here equal to value 1. If it's equal to value 1, it's going to execute whatever is in case, under case value 1. When it's done, break so you can exit out of the switch. Otherwise, it's just going to continue to execute everything in the switch. If this is not the case, if this is not the case, if this is not the case, then it's default. That's what default is. In programming, we call this trailing else, and I'm going to show you that. This was in, I forgot to show you that. This was, let's say here, let's open this real quick. This would be the trailing else. Trailing else means you have, is it this, is it this, is it this, is it this, none of these, okay, then it must be that. So that's what trailing else means. Okay, that's the catch-all, all right? And you're able to do it because here we tested the range, and because you tested the range, there's no need to do another comparison, right? So in switch, this part here, the trailing else would be the default. Okay, and you're going to see that in a minute. All right, so if you don't put a break, you can stack them. So for example, I have option 1, option 2, option 3. So option 1 is, let's say, check account balance. Option 2, 3, and 4 are to be implemented later. So ask the user, present a menu. I say, what would you like to do? And they have option 1, option 2, let's say deposit money, option 3, view, investments, option 4, let's say exit. All right, but the only code I have is for account balance for 1. And when they enter 1, I go and I display that break. I get out. If they enter 2, 3, or 4, because I didn't put break after 2, I didn't put break after 3, then whether they enter 2, 3, or 4, this is the code that's going to execute. All right, so just take a mental picture of this. It's going to become clearer in a little bit, in just a little bit, okay? So here is how switch and if work. Here's your else if statement. So imagine that we presented a menu, say, please select one of the following: checking account balance, withdraw, deposit, or for exit. What is your choice? And they enter 1. So 1, you just display check account balance. All right. And you're done. If they enter -1, you say, please enter 1, 2, 3, or 4. If they enter 5, you say, please enter 1, 2, 3, or 4. Look at the switch. What did they enter? 1. Case 1, see out, check account balance, break, they get out of this. If they enter, let's say, -1, is -1 equal to 1? No. Is -1 equal to 2? No. Is -1 equal to 3? No. Is -1 equal to 4? No. Then it must be default, so you enter 1, 2, 3, or 4. You execute the default. Is it making sense now a little bit how it works? How it's very similar to if, yeah?
Yes.
Okay, so now that you see it side by side, thank you. Let's go and take a look at some examples. So here, I'm saying enter a character. They give me a value, and then I'm looking to see if this is a vowel. And I'm asking you all, is there a problem with this code? Okay, so look, I have this code here. Let's do this. Let me see, what was the last thing we did today? I think 5 vowels, right? If I'm not mistaken. So this is going to be new. 6, we're going to do vowels again. So this is source code 06, vowels. And this is with switch. Okay, let's paste this in here. Let me paste it for your benefit in the chat so you can try it. So anything that you see wrong in here. Is there anything wrong with this code? Real quick. I have case A, case B, and the code works. I mean, it's nothing's wrong. It's going to give you the correct value. So look, the correct answer. As soon as this comes up. Okay, so I enter 8. And let's see what it does. It goes here and it says, okay, here it tells me that 8 is a consonant. Okay, so that's a slight problem. We can deal with that. We can fix it. That's not a big deal. All right, now, for the sake of this example, we don't have the logic for there, but for the numbers and special characters, this is just to determine whether it's a vowel or consonant. So I simplified it so that we can see what switch does. So let's say I enter a, lowercase a, and let's see what it does. It goes here, says this is a vowel because it's either any of these. Okay, so that's what it does. And then break and then return. And then when I look here, it tells me A is a vowel. When I do a consonant, okay, this time I entered non-debug. Let's say I entered U. No, let's say L. L is a consonant. Okay, so I'm asking, is there anything wrong with this code? Is this readable to you? Okay, guys, don't be shy.
Yeah, but it could be, we could do the same thing we did earlier where we converted it to upper.
Yes, thank you very much. So very good. So here we can just do 2 upper, and then we eliminate all these. So it's not changing it, but look at this. Look what happened to our code. Much easier to read than that. So here we stack them. So if it's A, E, I, O, or U, it's a vowel. Otherwise, it's a consonant. Okay, and we don't have the logic for is it digit, is it that? You know, that's just so that you can see how this works. Okay, so here if I put P, lowercase p, P is a consonant. And see, it prints it in lowercase, shows you that it didn't change it. It just casted it or changed it temporarily to uppercase so that you can perform that computation here. So you can evaluate this is an expression here as well. Let's say enter capital letter A. It says A is a vowel. Lowercase, let's say U, lowercase U is a vowel, and prints it in lowercase. Okay. So as you see how things that you learned, you build on that. You have that in your tool chest. Use it. Use it to simplify your code. All right. So that's an example. And I just put here, is there a problem with code? And now you know that what is the problem. And then what we end up doing here, we also can do something like this. This is enter a character. We do get car so we can capture spaces and all that. Then we go, is it a, and then see here, I put a Boolean and I just set it to true. This is long version. Then at the end, I can test is vowel, else is a consonant, and so on and so forth. Okay. So that's another example. Okay. So this shows you that you can use Boolean, and you can set it here. This is a little bit longer. And then I'm asking what happens when the user enter numbers. Okay. So something to think about. Now, where is this useful? Okay. So look here. We have a local company that's hired you to write a program that's going to track their t-shirt sales. And they have certain discounts that they give to their customers. So if you buy between 1 and 5, you get no discount. If you buy between 6 and 10, you get 5% discount. 11 to 20, 10%. 21 to 50, 15%. 51 to 100, 20%. If you buy more than 100, you call for special discount. Call this number and they give you special discount. So how would we write this program? Unfortunately, we are 3 minutes. I don't have time to show you this. So let's stop here. Before we part ways, let me make sure that we're on track. Let's see how far we are. So here we're in 28. We have branches. I'm gonna have to move your quiz, this one, because I'm gonna give you the remainder of this as because I have quite a few more things. Actually, no. I can finish this. If you bear with me, I can finish it. Rather than coding it, you'll code at home. So this is how you solve that. If you try, I was going to show you, if you try to write it and stack them, it would look something like this. Just bear with me, please. Let me show you real quick. Number of t-shirts purchased. And I don't want this to go into new line. And then here we're going to say t-shirts, and we're going to capture that like so. std cin into num t-shirts, and then we're going to switch on that. I'm just going to start so you can see how what I'm about to show you is more efficient. Then here, let's say just the first case. So you say case 1, then you say case 2, then you say case 3, then you say case 4, then you say case 5, and then you do a break. And then here you just display std D out and you say no discount. You say no discount, STD, ENDL, right? Then you have another range that they told you they have between 6 and 10. So you proceed to stack them. 6, 7, 8, 9, 10, like this. And then this one is going to kill you between 11 and 20, between 21 and 50. So if you start stacking them, that's going to be a huge and very unreadable code, right? So what do? This is what you do. This one is very, very elegant solution. Look, you have case one, very important that you put space, 3 dots, space, then the end of your range. And here you say no discount. From 6 to 10, 6, space, 3 dots, space, 10. Look from 11 to 20. Look from 21 to 50. I mean, you would be typing case 21, case 22, case 23, case. No, just do it this way, okay? And then from 51 to 100, a lot of cases. So 51, beginning of the range, space, 3 dots, end of the range. And that's it. So you make sure that there's a space that follows, okay? And then this I'll leave for you to try at home. I'm going to give you solution here. Need to write C++ program that's going to prompt the user to enter a character, and you need to determine this digit. See how you can do that. So guys, this is it. We're done with the conditional statements. I'm sorry I ran over a couple more minutes.